All right, so this is where we kind of stopped in the previous video. I hope you're definitely catching up and holding on to those questions, and you must have definitely got the answer as well, because now it's just the application of 1 in 60. As I said, I have a couple of questions, very good questions on 1 in 60 lined up, so I'm trying to squeeze those sessions as well in between. Only thing is my regular classes are keeping me occupied, and I'm finding it hard to get some time in between, but I'll definitely make sure I'll shoot them through this week. So having this particular diagram, make sure you draw the pictures quite big, because I have this distinct advantage of zooming in and out, which you don't have. So make sure you draw bigger diagrams. And we need to find the value of x, which is the closing angle right here, right? So I thought of just making a ready-made diagram for you from the previous video, but then I thought if you're watching this video for the first time, then let me just quickly go through the figure. And this is going to be a very quick elaboration, but if you're not really sure about it, please go check out my part A of this video. This is part B. All right, so we have the NDB here, and yeah, and we have a track of 206 degrees. We have the planned track of 200 degrees. We have seen all those things in the previous class. This is amounting to 6 degrees of track error. All right, and we do the aircraft somewhere around here on a heading which is equal to the planned track of 200 degrees. Perfect. Now this is a new track to be established, and say for example, if this is your destination, this is a new track to the destination, right? So go check out the previous video if you haven't seen this. All right, and we are kind of trying to find out this particular track change here, right? And we have also established the fact that a track change, which is delta track, is equal to the heading change, right? And once you have the change and once you have the initial heading, you can find the final heading as well. All right, that's the whole idea. To find the track change, we kind of divide the track into two different segments. The first segment being 6 degrees, pretty obvious, right? Heading of 200 straight here, and the track made good of 206 6 degrees of starboard drift. We are trying to find out this second angle x here, which we established as closing angle x right here. Right, this aircraft is also off from the track by this perpendicular distance, and hence this is the distance off. And this distance is given in the question as 180 nautical miles, and this is 120 nautical miles. So pretty much the same diagram drawn in the previous video with minimal information that is required. All right, now let me kind of name these triangles just to make it easier. This intersection point being O, starting from A, ending at B, and this intermediate point is C. Let's look at triangle BOC, because that's the triangle which can give us the closing angle, right? So remember the closing angle method for finding out the new heading and stuffs, which you've studied in your dead reckoning 1 in 60, right? Especially if you want to track towards a destination other than intercepting the track and following it, you can use the closing angle method. And what is closing angle? It is just a copy paste of 1 in 60 equation with very small modification. It is the distance off divided by distance to go, so to fly, into 60. Perfect. So closing angle is equal to, the distance off is something which you don't have. We need to find out. This is the distance off. Perfect. Divided by distance to go is 120 into 60. I'm going a bit quick on this, assuming that you have an idea about 1 in 60, and that is going to give me the closing angle. Perfect. Now we need to find out the distance off, and to find the distance off, let's get back to the triangle AOC, again right angled at O, right? Now applying again dead reckoning 1 in 60 in the triangle AOC, so you will get track error, which is equal to distance off again, but the difference here is distance gone into 60, right? So track error is something which is already there in the question, so to find out distance off, to find distance off, it is nothing but track error into distance gone divided by 60, and track error is there, 6 degrees we kind of established. Distance gone is 180 divided by 60, right? And that is going to be 18 nautical miles. So distance off is found out to be 18 nautical miles. Now applying this into this particular equation, so you get it as closing angle is equal to 18 nautical miles divided by 120 nautical miles into 60, and that is 9 degrees. So the closing angle is 9 degrees. So that's it. X is equal to 9. Right? And therefore, this is also equal to 9 degrees. And therefore, the total track change is going to be 9 plus 6, which is 15 degrees. Therefore, the track change is equal to 15 degrees. But fortunately, that's also our heading change, right? Now remember, this track change has to be made to the left of the track made good to track to a destination. It's pretty obvious from the figure, right? And therefore, your heading change also has to be made exactly to the same amount in the same direction, which is again 15 degrees. 15 degrees left. All right, perfect. Now, having that particular understanding, your initial heading is 200 degrees, and with 15 degrees left heading change, your new heading to destination will be 185 degrees magnetic, right? Okay, let's now think about the track. So you are on initial track. The initial track, or the track made good, is 206 degrees, right? This is 206 degrees straight here, which is your initial track. And we are kind of establishing 15 degrees left track change, and that is going to take you to the new track of 191 degrees. Remember, left turn is always going to reduce your magnetic heading and track. Perfect. So it's 191 degrees, which means this particular track right here is 191 degrees, on which you can draw the aircraft on a heading of 185 degrees. So the aircraft is going to be somewhere like this on a heading of 185. So I hope this particular diagram is clear. The aircraft is on a heading of 185 along a track of 191 degrees. As I told you, if you're not really sure about this diagram, please go back to the previous video, part A of this. I'll put the link in the description, and you can definitely go back and check that out. All right, perfect. So we have found out the new track as well as the new heading. Remember, track change is equal to heading change. And it's also important to understand the point that if you maintain your heading constant and equal to your planned track, your tracker is going to be your drift. Perfect. All right. That's it. So if you have kind of understood both these videos, I'm pretty much happy on how that turned out to be. All right, so let's move on to the next question. In that case, in this particular question, it's again talking about the NTB, but different questions of this topic.